In part B, we're looking at a union again. So we're looking at all the elements of both set A and set D. We'll go through this. We'll take -4 from both, take -2.5, take 0 from both sets, 1, 3, 31/4, and 25. That's the union of sets A and D. In part C, we're now looking at intersection. All right. Intersection is the overlap. It's the elements that exist in both sets we're looking at. So we need to look at set A and set D. We realize that 4 exists in both. That's good. -2.5 does not. 0 does. 1 does not. 3 does not. 31/4 does not. And 25 does not. So the intersection of sets A and D, the set of elements that exist in both, is -4 and 0. Now that you've seen an intersection example, go ahead, pause again, see if you can figure out the rest of these problems that we have here. If you need to, resume the videos and check your solutions with mine. All right, in part D, we're looking at an intersection again. This time we're looking at the intersection of B and C. Here's the nice thing, since B is the empty set, it has no elements, which means there's no way that B and C could share an element. So this is automatically the empty set. Now we'll look at the intersection of C and D. -16 is only in C, -5/2 is only in C, 3 is only in C, 21 is only in C, and 154 is only in C. Which means we also have these 3 elements only in D. So this intersection here is also the empty set. C and D do not share any of the same elements. And lastly, we'll look at the union of A and B. Now you have to be careful here. Even though B is empty, we're looking at the union, which means we're looking at all the elements added together. It doesn't matter if they share any of the same ones. So union of A and B is just going to be the set of numbers that we have for A, which we could write out that set, or we could just say that the union of A and B is set A. And that is the end of section 1.2. So, quick summary. We reviewed the 5 building block sets of numbers that we use in mathematics. We also reviewed how those sets are related to one another, that each set is a subset of the next set. We looked at size of sets. We looked at the difference between a finite set, a countably infinite set, and an uncountably infinite set. We were able to classify sets based on their size. And then we looked at set notation. We looked at using inequalities, so less than or equal to, greater than or equal to. Interval notation, where we either use parentheses or brackets, depending on whether or not we have that little equal sign in there. And set notation with the curly Q brackets, which is probably the most complicated and is one that we will talk about for the rest of this semester, at least, if not the rest of the year. Finally, we looked at union and intersection, where union is adding all of our elements together in all the sets that we're looking at, and intersection is only looking at the overlapping elements. As always, if you have any questions, you're more than welcome to email me. And for my actual students, you can catch me in office hours or in class, and we'll go over anything that is still giving you problems.